Hey, good morning, people. Now, let's just jump right into it. First off, shout out to all my lovely donators of the kitty cats and all that. And I ordered a net, see if it comes in a couple days, see if I can capture Nancy and Stephanie. And also that one is in the gas station. See if we can get a gas station kitty going on here. Okay, Nist Report states that the overlapping steel, let's just do that. It's not like that. That it's not enough overlap. All right. Yet we're looking at a member here that appears to be in good plane. That presents as in good plane without being flexed like this or separated. Yet this fell to the ground and we don't see this. All right. So not seen, but we see this. It's in good plane. So no matter what they tell you, they say don't believe your lying eyes. We're going to give you data that states one thing, and whatever else you see, your eyes are just lying to you. You're being deceived by your own eyes. Okay, so this is overlapping steel. This looks like the end of the steel here. See the circle? And the steel goes back. This area here is the spalled off concrete. Spalled off? Spalled off concrete. It's where the floor was at one point. And there's a rebar that goes into the floor, and that would be the bottom of the floor, and there's a section of rebar. There's probably more rebar here, just popped off. As you note here, it unzips. There's a pocket. That's a pocket right there. That's where steel was at one time. And it stopped right there. Now, it doesn't mean it didn't also turn like a development lamp, which I'm going to do a video for you guys on. That's a 90. There's a hook. And I think in one of my videos, I doubled down on I was calling this a hook. And I really meant, my brain just went. The way my brain goes doing these videos sometimes goes south on me. I have to throw it in the trash, but it's the only brain I got. So you can see that there is no, don't believe your lying eyes, Nist would tell you. This crashed to the ground. This was manipulated by a grappler, thrown around, everything else. And the best they can do is get this little bit of fracturing right there. Look above that line. You could zoom in to screenshot it. That's the best they can do after they mangled it with a grappler. As you look at the deformation, that is the shape, the profile of the reinforcement. See the X on it? That shows you that it didn't deteriorate, that it didn't wear down. It's very thin. It's not part of the main steel. It is part of the main connected, right? It's all one piece, but the deformations, the formations are made. And you can see it's, even though it's close to the surface there, it is still in great shape. You can identify it. All right, it's identifiable. Now, over here is another piece of steel I think that just popped off. So right there might be some necking. You'd have to look at it real close. Necking means when you're stretching a piece of bar like this, and I'll say I clamp it here and clamp it here, and I pull on it. Well, the middle would tend to neck out like that, get thin, or wherever it's weaker. This is that section here where a piece of rebar was, and it zipped out, pulled out. All right, this is the flooring. It looks like it identifies itself pretty cleanly here and here. I'm going to circle this line here and here. Okay, let's go like this. There's your reinforcement here, and there's your reinforcement there. Now, I think it looks smaller than the one above, than this one, just by looking at it. So it could be a piece of steel that was like at 90, like I told you. I don't know where this column came from, but I can tell you that that's bent over. So it bent there. So it had some, behavior. It still had some ability to bend, to flex. That's probably 1/2 inch rebar. And maybe that's, okay. So once again, you can see the profile on it. The hatch marks, right? The how they make it when they fabricate it. All right, it's there. They're still there. They're in great shape. That's the grip part. They would grip against the concrete as it locks. Well, it's not gripping anything. The concrete would interlock with it. Okay, so, but during deflection, it actually bent and did not pop. It broke free here, broke free, but bent there. So the rebar's behavior is pretty damn good. Now, so again, this is telling you that the columns lacked lapping. Well, I'm telling you, this column is not one of them they should be using to say it lacked overlap. Now, when you go to the upper floors, it's not that they lacked overlap. The building was shaking. The building probably would have stood perfectly okay had the building not been rattled. It wasn't designed for, as Professor Lehman's wheelhouse, an earthquake. All right, a shaking of the building, rattling of the building. It was designed to be vertical loads, under compression that way, vertical loads. And whenever you have compression, you also have tensions. You can't have one without the other, period. So you can't say that it's like being in a car accident, the car crumples up and you say, I see what happened here. This car was not designed to take the crumpling of the tractor trailer running me into a wall at 90 miles an hour. It's the cars, so the car is defective. No, you would understand that, well, a tractor trailer hit him. It was designed to drive down the road, and the tractor trailer pinned him against the wall, and it was to the 80-ton tractor trailer at 80 miles an hour, crushed him into a damn container, put me in a beer can, and killed me. Okay, I never felt it, but of course you guys would see the remains, and you would project that I was in some type of pain. It's not true. Right? It just happened so fast. I might have been able to bitch about it for a second, but it's only going to be for a second. I mean, not while it's happening. I'd be fighting it. Your amygdala takes over and you're just right in fight mode. So this column, don't believe your lying eyes, Nist tells you, is that this, I'm just looking at something and trying to show you the heads. Okay. So this one was probably like this, and let's do the top view. It probably, but when they were making it, let's see. So this might be a end wall unit, and this is what the rebar looked like from the top view down, bird's eye view down. So we can get rid of the circle. So this rebar. So here's the column. So let's do that. So this goes that way. This one's that way. Let's do this. That might have been a development left we're looking at. I can't see the rebar down here. I don't see it. I can't get any more images. You think I would be able to see it by then because this is set back in here to here. It does present as rebar to me, just so you know that I'm calling it rebar at this time. Can I change my point? Yeah, I reserve the right to change my position, but right now I'm calling it rebar like I'm calling that rebar. With that said, this rebar right here might have stopped right there, but then I would only have a tip to pull it this way. Okay, I think I see it. Okay. So, cone effect. When you're destructively, here's a bolt. Okay, so let's do it like this first. Here's a bolt. And that's the threads, right? These are threads. This is concrete. This is wood. This is whatever you want. As you're pulling this away, pulling up this way, it has a cone effect. It's like this. And that's the part that's going to fail. When you pull it out, it bursts like that. Now, sometimes you can just strip the walls and it pulls right out. But and that's the way it happens a lot with my rebar pull-out test, or they'll pop. But I mean, they'll pop or they strip or they pull out, is what I'm saying. You don't get this because it's not engaged enough. But if the wedged ones sometimes will get you, depending how deep you are. The deeper you are, the more likely it is going to just strip out your wedge. But the more, it's just some ratio that this amount of concrete that's above, so this is above part, will get you this blowout, this cone. Okay, let's change colors for you to help you see it. This cone. Okay, and I'm going to say cone. All right, at some point, if you go too deep, you won't get the cone. You'll get a snapping of the rebar. Usually it's at my clamp point where I'm clamped it. That means the rebar did not fail under, it didn't fail. What happened, the connection didn't fail. The rebar failed. So if I would up the size, I could do the test again. But if it's enough, it's enough. If considering the depth, it should be 12, 16 inches, epoxy, cleaned out, etc. With that said, the rebar the holding part of the rebar over here is just what you see to literally left. Imagine putting rebar in there. Lay that in there like a 90, like this. This section is here. All right, not this section, not that section, but this section is laid in that direction. We know you can see the way it is. Turn that direction. It's turned in a 90-degree direction, so it's 90 degrees. And when it gets pulled out, it's actually butting against this steel right here. See the steel there? Now, the steel there is here. Let's just do like this. And then this steel here, well, it goes behind it and comes up. And when it pulls out, it just slides out behind this connection. No, it did not. It did not. So if that's the case, that means because it would have pulled on this steel. So literally, now that I know I can't have that connection like this, so that's this. Let's do this. Let's make this one red. All right, this is red. All right, that's red. Let's change colors and go to yellow. This is yellow, fellow, right here. And now let's do the rebar like this. All right, as it unzips, pulls out of this pocket here. I'm going to take this away in a minute. It's able to slip behind this steel right there because we look at it and we see it drug behind it and it didn't even pull it out. So, oh wow, that's amazing. Or, I'll get rid of it. Or this yellow one there was like this. So here's the red, you see the red steel. It was like that. So this will be the end of our 90, our section here. This is the tail, right here, the tail. And there it is here like that. Coming, probably wire tied right around it a little bit. Maybe they wire tied it. Nothing, a little small tail coming out. Very past this part here. Very small. Just enough to wire tie it up. And so I would see that. That's what I see. And then it goes across the flooring. So you would, if you could turn this picture 180, which I think I actually can. Hold on. Can I rotate the image? Apparently I can't right this second. Okay. So then you look at that and you go, oh, I see. I see what you're saying. So let's go back to yellow. So that was there like that. The question is, was this piece, was that part of the head? Are we looking at this going down and this is the other tail part of this head? And then a pop right there. It's in line with it. It can be turned. You can twist the rebar a little bit, so this would work still. It would give me... It's a tough one. I mean, I'm going for that one. The other one I look for is, remember the cones? So this appears to be a cone. See the clean line right here? You lay a piece of rebar in there and you pull it out and you get that nice clean look, that nice clean, and it's in parallel with this one. This one holding on more so, pulling out more rebar, making a bigger cone to snatch it out. As we look at the concrete itself, it's pretty tight. Look at that. That stone and the paste around it, the sand, the mortar, if you will, everything, it's tight. All right? Tight. And it's been already grappled and moved and manipulated. Alrighty, alrighty. So for them to say that it's the overlap, again, this is Professor Lehman's wheelhouse with the earthquake thing. And also, I think it's the lady that the one that's running the program, the head of it. Initially, I was biased against her, and I did a video talking biasly against her. But I think she also looks at after earthquake things. Maybe she doesn't know what she's looking at, but if she did, she would look at the behavior of what each connection looks like as it hit the ground, and you put the data together, and pretty soon you're able to start coming up with an idea of what's going on. So maybe like the impact of the ground here, maybe this is not existing because I don't see fluorescence salts. So when impact on the ground, that piece of rebar, this piece of rebar, which is probably down here also, gave a little shatter, it's little fracture, and that's how it, how it behaved during this collapse. But this one, don't believe your lying eyes when they say the overlapping steel. Yeah, the overlapping steel is, a transition. It does it a lot like this in transition overlapping steel, and so the flow path is like continuous here. The stagger, I'm going to be real clean about it like that. It's a little more gradual than that. And here's your overlap. Here's your continuation of that steel. In this case, they just went like this on the outside. It presents as that. I would need to see more of it. So let me see what else I got here. So then I forget which one it is. This is New York Times or something like that. This doesn't exist, all right? This beam here doesn't exist, all right? It doesn't exist. So the load path of the structure doing rattling, first you've got this 1'6" step down, which is here, 1'6", and step up. And this is into your structure, your first floor. All right, so let's do it like this now. They have it there, so we'll keep that as the height for the 1'6". Let's do it again. Oops. Let's do it again. I'll make your smallest section. All right, so this the 1'6". The 1'6". That's your pad. This is your lobby area. All right, so this is the lobby floor. 1'6" right here. All right, then there's that slab detail that goes over, and that's your deck out here. Your deck goes that way to the right. All right, so the load path, I want you to remember that. So let's go here to yellow. So the load path goes like this. Then it shifts, and then it comes across, and then it comes back, and then it goes like that. That's the load path. This, as I wrote here, doesn't exist. So this doesn't exist. This doesn't exist. I know that they used all types of architects and engineers to do their drawings and all that, but it happens. Mistakes happen, but that doesn't exist. All right. So the load path shifts inwards. Now the floor is still there. The floor is still here, though. There's a one here. So here's your floor, right? Your floor height. It's continuous. The floor, but the floor has to span from this column to this column. The floor span is now great because there is no the support system with a little bit of with that column right there picks it up, but the span, and that's where that car's parking is, but the span with these BMAs, and again it's BMA, not Beam A. Nist made it clear it's supposed to be a post-tensioning bar. This is part of the drawings. It's a post-tension bar. BMA. There's a BMB. Look it up. Don't trust me. Try to debunk me. This will be the great one for like tool time. I got him. Clown face. Anybody. Just join in on it. Try to call me whatever. Even Nist it's in Nist's own report. So even Nist knows it's a BMA and not a beam type A. With that said, this is 1980s. The guy wasn't very sharp and clear about BMA besides giving it away in the detail section where he states post-tensioning. Pre-stressed. I believe he states the words pre-stressed. And it's kind of weird that he said pre-stressed because it's actually post-tensioning how this works. The BMA is post-tension, not pre-stressed. And yet the drawing, they do talk about pre-stressed concrete, which is, I can't say post-tensioning, but you guys understand post-tensioning better. There's a difference, pre-stressed and post-tensioning. In this case, the BMA is a post-tensioning. It's a bar, a rod in there, and you crank it down to take the extra loading. All right, so it's in the drawings. It's the only place it could be mentioning would be a BMA, which existed then. It was a term then. I want you to show you the load path again. And then back into the structure here, okay? So it looks like that. So the load path is open here. It doesn't exist. That X where I put the X, that does not exist. A floor above exists, but it has to span. That puts this load back here. The load path during a rattling or shaking of the building, you lose that, and you lose the continuity between here and here. And what has to take it over is the floor. The floor in room 111. I think it's 111, has to take over to continue the load path, the shifting action. I'm going to do this, going to do like this, like a shearing back and forth action. Now part of that's the building abutment. The building is here, and then on the other side we have the building to your right, and it has a shear wall. The shear walls go in this direction. This is the shear wall. Goes in that direction. So where do we get shear wall this way? Well, there is no shear wall on that entire panel, that entire outside wall of the structure of the, as we face the pool, as we face it, as we face the structure, there is no lateral shear wall, right to left. There is, or left to right, which would be towards the ocean. I got that right? Yeah. Towards the ocean. And so that would be east and west. There is no lateral shear wall there. So it doesn't take much to tug on the building, and then you've got nothing to stop it. You just got glass planes, the floor's all in that level, everything's in that plane. There is no shear wall going this way. There's shear wall here. It's not a shear wall. This was shear wall is continuous. It's the staircase. It's continuous. And, I mean, maybe I can reach as far as back inside there and say, well, it's a micro shear wall. If it all goes all the way up and they interlocked it, but it's too far back. All right, but there is none. So you can get an easy shifting, and especially with the, but the failure is at the penthouse shifting, and I show that with the complicated boxes I use and show how the roof fails by using the ductwork. You guys can ask me for the link. I'll give it to you. They're using the ductwork, and maybe I can find it. The ductwork that shows how it had to clear it, because the ductwork is so significant in telling you how it could not have failed. It couldn't just fall straight down, or that ductwork wouldn't be on the building. So this, oops, wrong one, and that's him. So this is 111 here. I believe it's here to here. Okay, 111. Ah, shit. About number. Okay, number sign. All right, this is that shift I talked about. Is that you see right here? It's a 7-inch. This is 1'6" on the other side of it. This is also 7 inches here, I believe. So the load path comes over, comes through here, comes over to here, 11 inches, then shifts again, comes here, goes back, and now we're at the 1'6" again, and 1'6" to your left over here too. But to keep this load path together, this is where this BMA, would work in this capacity. Now, BMAs look like this. This is an anchor. This is a rod anchored inside the concrete here. And the live end down here is where you put the tensioning on. Here's the column. And you crank this together, and it makes a tight joint. This BMA makes a tight joint, an interlocking joint, not just with rebar and concrete, which apparently they did. This is a bar, a rod, a all thread, a thread all, however you guys switch it up, and that's the size. And here's an anchor embedded, and you crank it up tight enough, whatever you call for it, and it makes this tight joint, makes it very rigid. This is 11 inch right here, and this is 11 inches, that step down. So even though they got 1'6" over here, right there in the circle, 1'6", they do 11 inches here, 7 inches over here. All right, so you can see the path. The load path as you're building, as the deck goes down. If you get rid of these two, you only have now the inside floor of room 111. Room 111, making it the load path from the 1'6" over here to the 1'6" over here. I'm not saying that's where it buckled. I'm saying the roof was what the issue is, but this is addressing that. Let me get you something else and call this video a wrap. So for you newcomers, maybe, this is where rebar was. You see the black channel? It presents as black channel. Well, this is the rebar right there. I'm going to move it in a second. It goes back up into the air. And it unzips. Now, I heard, I think it was Josh who said he doesn't like the term unzip. Unzip's been used forever. It's a real term. All right, so part of this, what you're looking at, is demolition that's been done. And over here also, it can crank over and you rip off the rebar. In this case, you just ripped off the rebar. But notice this is the rebar. Right here is the cone. All right, there's your cone, a mini cone there. It's cleared out. And most of it came out, but there's a mini cone as it evenly pulls it away. Now there's some rebar that was across this section also that it had to pull down. And again, this was demoed mostly, this part, because the pool deck by the pool didn't fail. It failed over to this line here. It's like a construction joint. Well, I'm not sure how much I was just spending talking, but let's go over it again. I think I messed up. So for you guys, so if if I'm repeating, please bear with me. This is the rebar that was in here. Okay, let's zoom that in now. And you see it? That rebar, this rebar here, was above in the ceiling. Engagement-wise, I see some paste on it here, paste here. Some rusting, but I can still identify the grip force. And some swelling actually can be beneficial, some increasing your bond. There's some wire here. And then we have, so that cone effect of pulling it apart. So I can even tell you back when they installed this rebar, how well they consolidated the concrete. We can look at the stones and see if they're stockpiled up or they have paste around them. We can look into the tracks where the rebar was, and we can see the dark part, the profile, the ribs around there. So they actually did get good consolidation around their rebar. So this is important because we have to worry about the illusory truth effect, also known as the illusion of the truth effect, validity effect, validity effect, truth effect, reiteration effect. So, and also the halo effect. All right, look up psychology, halo effect. So Nist has made themselves the National Institute of Standards and Technology, right? They now declared themselves that. So they don't give their qualifications of each person. as far as saying, as far as saying, they say what in general that they do, but they don't say, you know what, I actually discovered this or that, this or this, and none of that pops up. All right, none of it is extraordinary. All right, none of the stuff is extraordinary. I looked at each one of the on the Champlain Towers and also on the investigation with the Florida International Bridge collapse. None of them have any outstanding work. None of them do any publications like this. None of them take the risk of opening their mouth like this. They do it through. Now I don't even know if they publish. They don't have to publish anymore because they've automatically been decided that they're the narrative, and you can't take their narrative to court because they can't prove it. So it's whatever their narrative they want to preach. So be careful of that, of any government telling you that, this is true. I showed you that Nist was destroying evidence, throwing it away, and part of their evidence in one of their videos, they actually show that as evidence. I'm like, well, that's the evidence I know in the video, and that's when I got shadow banned. That's the evidence that I show when Nist destroys evidence. If you guys Google Nist destroys evidence, maybe it'll come up in a Google search, that video, and you'll see the live where they're just tossing the evidence, the reinforcement, which is evidence, added away just because it's whatever reason that they didn't address that. So this is illusion of truth. Be careful of the halo effect, and also the illusion of truth. It appears that Nist, and a few of you have written me such, are ignoring the loading of the cars in this section here over top of this column. The rectangular array offset, this column here, is out of bounds, all right? It's out of bounds. The column should be there. And that degree is so far out per the plans that it should have been spotted by everyone and anyone. It was not out of bounds when you put the BMAs back in. It had a BMA there, but when they did a deck elevation change, became one deck elevation from a step up over here, which I believe they have in the newer north building, the current north building. That step up also has a crack in the wall, I believe, over here, which is indicating of something a little funny, a little fishy in Fishtown. Fishtown's in Pennsylvania, Philadelphia, right? So anyway, this one is your K, and I called it a long time ago when I said rectangular array. And yet, Nist, instead of beating around the bush, as the guy who spoke up against Nist in that meeting said, look, you got 25 hypotheses, and you have theories, and you have not eliminated one. You haven't even eliminated a car running into it or a bomb. Literally, they haven't eliminated those two either. Oh, really? And they're still doing hard drive finding. This is multi-millions and millions of dollars. How many? It just doesn't make sense. It does make sense because they're government, right? They want to use every last dollar. And the insult to injury is that they use FIU, Florida National University personnel to help evaluate this. And Florida International University, being an engineering school also, didn't do their own video on the bridge collapse, their own bridge collapse. Now all of a sudden they want to come forward and talk about this collapse, and yet they can't even do their own bridge collapse video, which they have the most content of. Isn't that, you find that a little amazing, right? All of a sudden they want to speak up. Well, we can investigate, we can help in this investigation. That one lady there, how can you help in this investigation when you can't even do a report of an investigation of your own building that you have inside knowledge to? So I forget I have to give a shout out to, but we'll get to your content. You sent me a link proving that this had this huge coping on it. I want you to look at this detail right here to here. There was a huge coping at one time in that area that they used this profile that was like, so here's the pool, and it's huge, and then here's your pool deck. So this existed. And remember, they talk about this 9 inch, that's sand bed and all this other stuff. Well, then there's a concrete floor there, and that would go over to here. And then you can try to extrapolate to where it is here. Right? Is it down? This looks like it's tapered. So is it here to here? So here to here, or is it here to here? Well, paint-wise, paint's on here, so I'm going from here to, we're getting right about to there. And then they added that up to 9 inches, as he states in the photograph. But there's this huge coping. I'll release that in another image, perhaps. So this is sort of a summation video to get people up to speed. So notice the current and past users also of the content. Notice all these striations. Those are your rebar striations. Rebar from the back that pulled out of the column, out of the support wall system. And some of it had bent over the rebar because it's interlocked. So this rebar is vertical. Yeah. So this is looking at it from top view down, vertical, and then there's steel wrapped around it. As concrete falls, it grabs hold of the steel and pushes it forward, and there it is there. Cranking it over, if you will, pull like you were having your hand on top of the bar and cranking it over as it was standing proud, and put your hand up here and pull it back. That's the force of it means the concrete was still behaving, trying to hold on to the anchor points, to the walls. And as it broke free, these are indicators of the rebar scratch marks, all right? Reinforcement scratch marks on the wall. Now, Nist would like to tell you that overcrowding of steel weakens the structure, that this overcrowding weakened the structure. Yet they showed that they had to use explosives, and anybody who does demolition, all the demolition companies charge an extremely amount more money when they run across more steel, because the building is not that it's weaker. It's going to take more explosive and a lot more coring and deeper cores to make the building fail. So their little 3%, 5% steel rule is just made up to save money. It is not structurally stronger. They said it themselves when they said, "Oh, their overlap kind of sucks. Their overlapping steel kind of sucks. It lacked enough overlapping steel." Huh. Well, if you only needed so many percentage, we don't have to worry about that much, do we? No. Again, remember, this is not it, because it was a compression. It wasn't shifting laterally. It was no signs of that. This is during a collapse mechanism of failure. It's not, even if it wasn't rated. The deck was what's the issue here. The deck is the issue, not the building. The deck and the building connection. As the one engineer that followed my channel there, that did that, WCJ, stated in his thing, talking about referencing me, because I'm the only one that referenced it. And then Tool Time stole my information afterwards by referencing it after I already published it. That you need a fuse, as he stated. The one guy said that I stated you need to fuse something to break the building from the deck from the building. And there you have it. And then Tool Time, guys, Tool Time's a cell phone guy. I don't claim that. Well, I do have a lot of knowledge on cell phones as far as their sharing data, third-party information, how it works. But I don't claim to know how to fix a cell phone. But Tool Time was apparently a professional cell phone repairman. That the guy could. That's his engineering degree, repairing cell phones. As far as what somebody informed me, and what he said in one of his videos one time, and I never forgot that. So, does this look like a cell phone? Any part of this looks like a cell phone to you? Doesn't look like a cell phone to me. So some people are, just doing it for the financial gain. I'm doing it to share the knowledge, to help you guys get smarter, the engineers and the general public. So here's that step back I talk about, where you step back, where, as you show in the drawings, let's see, so here's the plane of the building, and then it goes over, like this. It's the plane of the building here. And this is, in essence, the path. And then they have a column, continues over, and then a column, continues over, column, continues back towards us, column, continues over, column. All right, but there is no, so you have the floor section in here. This is the floor slab number 111. All right, so that makes it weaker there. It shifts it out. So any failure back here, all of a sudden starts affecting the structure, the main structure, because that's how it continued to load path laterally, left and right, as you see in the image here. And it can't do that if that's on the ground. It makes a void. And then the floor deck, room 111 floor deck becomes the structural load path that gets us across from one side to the next. From here, connecting. Connecting from here to here is done now in the floor of room 111, the floor of room 111. That then gets back to the 1 foot 6 inches over here, which was supposed to be 2 foot 6 inches. So that's the significant, as I said, Cadillac money. As I told people that was a lot of Cadillacs they saved by elevating the deck and dropping a foot of concrete out of it, 1 foot thick of out of this drop slab detail, slab drop, or drop slab. One of them they call it, not to be confused with a drop panel. So the car, the ramp coming down here, the car, question is over here, I believe. Did I get that wrong? No, because there's the column. It's got to be here then. There it is. There's your car. We see that in the image of the lady who takes the video. We see the car image. All right, the only one that's driving everybody crazy is that column there. Does it exist? I think it does exist. I think it did exist. They had a chance to reveal this when they removed the decking. It would punch through if it punched through the deck, then we would see a hole in decking, and this hit the ground first. If it got pulled over and buckled over, remember all that steel there we saw that they show, none of them showed folded over to the ground like that. And yet this decking's on the ground. Keep in mind that the decking is, looks like this, profile-wise. All right? But this gets straightened out. Let me show it to you. So here's the image of there's the water coming down. And then here's part of the deck or flooring. And then there's the other part of the deck. And I believe that's your column where the car is parked back there. I've already enhanced that. And there is the other column inside, the planter box perhaps. So with all this destruction, this is the best you can get. Look at that steel sticking up. It didn't bend over more. With all this destruction, wherever this is located, it still couldn't bend it beyond that because the concrete down here act as a pivot point, a moment connection, a immovable clunk of concrete. Clunk. K-L-U-N-K. Clunk. Yes, that's the way I spelled it. So now it rotates upon that clunk. Yeah, I have a lot of fun. Here's one. All right, man, the deck, it's all mangled up. That's obviously explosives, maybe, because it's all twisted to hell. What are these? What are these little things sticking from the ceiling there? Well, they're little bars they stick down through the concrete just to check the bottom of the concrete. Now, or are they this? They're chairs. See a little turn on them? And you put your rebar, hold the rebar in a certain place right there. and there are chairs. They hold rebar, and that could be two different, another direction, another layer above it, because I think it might have come out. You don't wire it underneath the chair. It sits on top of it. This is where the bottom of the deck was. It sits on the deck. Those little steel. I did another video where I talk about the roof failure and how it's pretty easy to start understanding it, especially with the ductwork one. But for example, here's a door, right? There's a door, and you can see it's wrinkled there, and the top of the door is bent over. You can see the impact right there, and folded that door over. So we got a header, we got a rotation inwards, not away. So we can fold this door. You can only fold it one way, and we actually have a swinging back and continuing the fold to close it down. So before it's released, it swung into this area here. This is a door jamb. That's a piece of metal buck or steel. It's called a buck, steel jamb, wooden jamb, however you choose it. I've gone over a lot of this in a lot of details, including this beam, this tie beam at the top, solid pocket fill, rebar. I went over a lot of this. I think this image might make it more clear of the load path. See? That might make it more clear. This is 7 inches. This is the floor, internal floor here, level 111. And there's a little column there. It wouldn't matter how that floor is supported above that, on that column. And this is the post-tensioning I talked about. Even though they say pre-stressed, which means beforehand, it would go through there, tie back, and you would bolt live end here, where you would tighten it up there, and here, and the bolt would go back about that deep, however they decide. The bolt, the all thread, if you will, and you can imagine it being bedded with an anchor, and then you pull it tight, and that makes this joint a firm joint, a very sturdy, firm joint. They had the right intent, and then they didn't do it, I don't think. So in this one, the same article, they sort of get it right. They leave out the connection here this time, which is great. But they didn't elevate the deck higher here, and then the floor is here, internal floor. So this would be elevated. Also, they created this is the car coming down. They don't have, it's another one here. It's like they just made this huge pocket, they put it out here, and then back here. You see it? They just left out the other cross member, which is staggered. So it's 7 foot and then 11.7. So yeah, this one's back here like that. If I got that right, 7 foot on that side, and 11.7 over here. They use 7-11 a lot here, and this doesn't exist. This is not like that. It's terrible. This doesn't exist. Doesn't exist. But the BMA deal would work like that, and then anchor point, rod, anchor point. I mean, live end where you crank it up. So now this is now there in this rendering, and this is correct. Rough submit, but this is wrong. So looking at the load path from this direction, we come this way, and we turn, over, turn, and then back again. All right, so the columns here. That's also this is a drain. You see around there, each one of those flower pots had a drain, and there, and then this one was here, I believe, and then we have our nasty one over there. All right, so then we have our connecting, which is there, that little piece there, and that little piece there, and a little piece there. Those are connecting to close it up. And again, BMA post. Let me just get to that. So this is a Nist study. All right, Nist. This is page 30. If you right, drop the ball on that one. That's the guy who did the study. Yeah. All right, so page 30 of 110, look up Nist BMA, maybe you'll find it. Okay, a series of 7 precast beam column connections were tested at the University of Minnesota. The connections detail varied from post-tensioning, with 2 post-tensioning, that means after you put bars, 2 post-tensioning bars, also known as, in parentheses, BMA. All right, not beam type A. So everyone who keeps calling it beam type A, I try to play along, but I want you to know I don't believe that it's true. It's a beam type A, a BM-A, or beam type A. It is a BMA. All right, it's mentioned there. BM-33, beam 12, beam. He mentions them. He speaks of them. It's the BMA that's written over there is ambiguous, but it looks more like a turned up beam than not. Okay, a connection with 4. If you use 4 threaded rebars, you get a BMB. All right, if you use 4, so here's the end of it. If you 1, 2, 3, 4, it's a BMB. A composite connection is a BMC, consists of a CIP topping, let me move this out of the way, and a precast connection with post-tensioning bars. A welded connection is a BMD. A bolted connection is a BME. So this, as I described, would have no choice but to be a BME. All right, so 1 bar here, 1 here. There's 2, well, it could be more than 2 there, a BME. So this would be 1 and 2, and then you bolt it at the end. As I told you guys, here's the column, here's the beam, and then you would look like that and post-tension it afterwards. Let's clear this up for a second. But he states a BM, come on. He states the connection details vary from post-tensioning with 2 post-tensioning bars. It's a BMA, all right? So that's your post-tensioning, your 2 bars. Now let's go back to BME again. A bolted connection is a BME. So the post-tensioning bars are like what you saw on the FIU bridge, where you just pull on them and do that. The one I stated is a bolted connection is just nothing. It's just a clamp connection that you just bolt up. It's not the same as this. Oh, I guess I should have said not to be confused with the BME. I'm sorry. Let me retract that. Not to be confused with the BME. So, but he says it's post-tensioning. And that's what a BMA is. See? BMA. The problem is that the drawings say pre-stressed concrete. There is mentioning of this pre-stressed concrete, but there's only alludes to post-tensioning, which is BMA. Again, look at this, guys. I'm not making up this BMA thing. It's not, and I know a lot of people trolled me on and think it's beam A, it's beam type A. All right, that's with your skill set, your knowledge. You lack the knowledge that I'm now giving you. So it's a B, and I've given it before. It's a BMA. It's not a beam type A. And when they removed the BMAs off of this structure, they changed everything on that deck. A parking pool deck. It's a parking pool deck. They're on the same elevations. Since they didn't have the BMAs that would make the different elevation and structurally different, they now made it a pool deck that they park cars on. That's because it's all one continuous deck over. They now made a pool deck that they park cars on, which gets worse around the car area because the columns go all the way through, and the steel just goes through like wherever it goes through in that area there. And when they added that dead load of the concrete, it only went to there. All right, it only went up to the column. Keep that in mind. At the parking garage, the concrete only butted up to the column. On the pool deck, watch, I flip this around now. On the pool deck, here are the columns, and the pool deck has concrete over top of the columns. All right, it's over top. And when they add the overlay, shit. We'll do this, and this is the pool deck. You can make it large, right? This is the pool deck, all right? So the pool deck goes over top of the columns. All right, and when they add the overlay, they go over top of the columns again. But the difference is over in the parking garage, this would be the column now. This overlay goes up to the column, and so it's a dead load that has just has a greater value, weight dead load on top of there without getting any value of the column in the background. See, the column in the background helps support it still when you go over top of it. So there's a different behavior in the pool deck columns and the parking garage columns. The parking garage columns are here, how the overlay works, and the overlay over here, you get some value of it being over top of there, a continuous overlay over top of the heads. So again, a BMA, and yeah, look at it. Does it look like anything what they describe? Would you think beam type A? It says the connection detail varied from post-tensioning with 2 post-tensioning bars. That's after the fact. And, parentheses, we know them, aka as the Nist Report knows them as a BMA. A connection with 4 threaded rebars. Threaded rebars. See what they said there? Now they added the word rebar. So this is post-tensioning with 2 post-tensioning bars. For clarity, these 2 post-tensioning bars appear to be threaded rebars. So it's like the Baltic connection again I'm talking about. Now it's a BMB. So for you guys, if you do your research, this is a BMB. And this is a 2 connections BMA. All right, so... So now inherently, the bond strength gets weaker as you go taller. From the 8th floor up, there's 4,000 PSI. All right? And the remainder floor up 4,000 PSI up to the 8th floor, and then the remainder floors are 3,000 PSI. This inherently makes the top floor weaker, the bond strength. So that's why I can have it the top-down failure upon shaking, upon this earthquake effect. It gets the top floors 3,000 PSI remainder. They reduced it significantly. Here's the parking garage column area I was talking about, where they can only put the dead load on top of this existing slab. The dead load goes on top of the existing slab. It can't go over top of it because there's a column there. Whereas the pool deck, when they go over top of it, it can go over top of the columns and you get more value from it until you don't. And that would look, in place, it would look like, it would look like that. In place, the value would look like that. See that? And that's a control joint there. A construction joint. Sorry. Control joint is where you like it to crack. And construction joint is designed to be full separation like that. And once again, so this one you would get the full value of going on top of. This one you would be butting up to the column. Butting up to, and this would be fully over top of. Now that's back into, no, that's, yeah, here's the, yeah, that would be fully over top of. And then this one has the planter boxes, that's butted up to, so that's dead load up to, not over top of, because they didn't remove the planter boxes. Then you got the car loading over here, shock loading of the car loading. There's a BMA that doesn't get used. All right, that never takes place. This is a BMA. All right, that's a BMA. That's a BMA. All right, not beam type A. Nist, we got to go back in time and reference what the engineer was thinking, and he's referencing BMA. This is one of my first reveals where I talk about, wait a minute, there's no BMAs present. Where are the BMAs? This one I first discovered through imagery that this isn't a BMA. There's no BMA across there. Well, actually, it would be here. I think here also. But there's no BMA here. And so I was, discovering that, oh, they don't have them. This is one of my first ideas, thinking it's the first zone, second zone, construction joint, and what I say, takes down part of penthouse activity. Right. Here is that parking, the area where we see, this is where the car would be, and there's the ramp. And this is we see from this view with the camera. As you can see here, I'm going to remove this in a second. It's all flat, pretty much flat. Remember, it's a step up like that. So this flattened out, probably went like that. Right? But as we see it in the video, it looks more like, as we're looking down the video, down the ramp, it looks more like this, doesn't it? Looks like we got two layers like that. So that's just that BMA, I think, giving us a cross member giving us so we're on a ramp, we're looking down, and then it's profile like that. Remember, we're looking down, so we're getting a different profile view from it, looking from the view across the street, approximately 6 foot off the ground. She's looking down a ramp, so we're getting a perspective that's totally different and zoomed in. Totally different, but this is where we can see it punch through. This is knocked over now, and they broke off that section. But this looks like flat decking, and this looks like see that rough right there? I'm going to remove it in a second. As that deck has a change in elevation of 1 foot, 11 inches rather. 11 inches. That when it laid down flat like that, they scratched at it with this excavator or another excavator, and they tore apart the cover rebar, the cover concrete, and now you see what exposed is rebar. That's just rebar exposed. Of course, you don't see the planter box. Of course, they could have filmed this, but of course, no one filmed it that we know of. Oh, and here's Jeff over here trying to take some data. DOS, thanks for sharing that. And then I screen captured Jeff trying to jump in when you're trying to share with me. Kai, see the March 23rd images of the link I sent you. Then Jeff tried to steal it from my man that was sharing to me. And DOS made it clear that I might want to analyze those photos, then make a video. So watch out for the hyenas. I'm sorry, I can't do the editing for that right now. Okay, to end the video, shout out again to my cat lovers and cat supporters. I'm working on trying to save that cat that's in the garage, out there at the gas station. I ordered a net, waiting for the net to come in. So there's that one. The details where the splicing takes place looks like that, where I showed you, remember? And there's a continuation right there. And there's the overlap. That's the way it looks like. Again, it's like trying to blame, saying my car couldn't take the impact of an 80-ton truck. Yeah, it wasn't designed to take an impact of an 80-ton truck. Nor was this building designed to be, like take the earthquake movement in such capacity. All right, it's just not required. It would cost too much money to do that all around the country. But the deck and removing the BMAs are a big issue. These dovetail details are awesome. With that said, I go to this page of the structural drawings, and number 12, all precast, look at that word right below the dot. Pre-stressed units to be designed. Pre-stressed units. This is remember, it just doesn't have to be a cable. It can be a rod. In this case, they do say pre-stressed. Remember, BMA, though, is not pre-stressed. This is so weird that they state that, but they nowhere do they reference anywhere in this drawing pre-stress besides BMA and not beam type A. And so to tie into this detail number 12 in the structural drawings here, all pre-stressed units to be designed and manufactured in accordance with the applicable ACI standards. This is of structural sheet S11, dated 8/22/79. This is the 135 unit structure. So this is the south building. Just so you guys know, I'll move it out of the way a little bit. And that is S11 of 14, and there it is. So I'm going to end the video with that. And again, thanks for all your support. Thanks for watching. And I'll throw this on Rumble also. Let's see if that, I can't go anywhere else with it, right? And yes, this video is 1 hour and 1 hour and 6 minutes long, editing-wise. Oh, yes, I'm exhausted. Oh, I think I have 3.5 hours just to give you this with the edits. So sorry that I don't introduce any cats. I'll put it in the 1 minute clips. The cats in the 1 minute clip videos, I think. And we'll do it. We'll double dip that way. So Carolyn, and Pugface, and Zachary, and Christine, and all you others that keep giving in the PayPal, etc. I really appreciate your support. It goes back to the channel, and unless you say it goes to the cats, in which case cats are getting fed, which is awesome, and that's also my wish list. I moved the wish list over to Rumble also. You can still use the wish list over there. Oh, was it Carolyn? You got Stevie hooked up on those little nuggets you sent in the bag. He doesn't want anything besides those nuggets in the bag now, so I've already ordered them. He's like George. George held out one time for a certain amount for certain food. He said, "I'll starve until you get me that food back." And so finally, I got him over to wet food. But Stevie's like that now. He's like, "Nope, I'm not eating until you give me that bag with the organic bag, whatever it is." So I've got another bag of organic that I'm going through for him. He's just so cute, but Stevie's holding out for those nuggets, those in the bag. But we know dry nuggets aren't good for boy cats. So I'm monitoring him, and I'm trying to dilute it with some wet food, and he's like, nope, just like George. He's so stubborn. Okay, take care. Love you guys. Thanks. Bye.